Here is question number 10 on the quiz of quadratic function. Says consider f of x equals to x minus 1 square plus 1. Find f inverse x. Why f inverse x is not a function. Explain how can you restrict the domain of f of x so that its inverse is a function. Okay, right. So the part A says find f inverse x and why inverse x is not a function, and the part B is explain how can you restrict the domain of f of x so that its inverse is a function. Okay, so you copy down the question and try to solve it, and you can pause the video at this time and then later look for the solution. Well, let's follow the steps to find the inverse of a function. So how do you find inverse of a function? So first step is write the function with y instead of f of x. So let's do that. So we get y equals to x minus 1 whole square plus 1. And second step is swap x and y, right? So to find inverse, we write x equals to y minus 1 whole square plus 1. And then the next step is to isolate y. So we can do that by bringing 1 here. So we get x minus 1 equals to y minus 1 whole square, and now we square root it. So when we square root both sides, we get y minus 1 on the right, but on the left side we should write plus and minus, correct? Look for my video on a square root is plus and minus, right? Is absolute x. So whenever you square root it, you should write plus and minus of this, correct? And now from here I can write y is equals to, let me bring 1 this side, so I write 1 plus 1 minus square root of x minus 1, correct? Now I can write from here what is f inverse x. So this is f inverse x, right? So f inverse x is equal to 1 plus and minus square root of x minus 1. So that is f inverse x. So is it a function? Clearly it is not a function. Why? For any value of x we have two values of f of x, 1 plus square root x minus 1 and 1 minus square root x minus 1, okay? And therefore we don't have, or therefore the function, the inverse of this function is not a function, right? Now the second part of the question asks, how can you restrict the domain of f of x so that its inverse is a function, correct? So for that, let's try to understand how this function will look like. X minus 1 whole square plus 1, correct? So this will be like at a vertex will be 1, 1, and it opens upwards. So this kind of function is kind of like this, where this point, vertex, is 1, 1, right? If you see, this function fails horizontal line test. So if you draw a horizontal line, it crosses the function at 2 points, and therefore its inverse will fail as a function. But what you can do is you can restrict the domain of this function so that it passes horizontal line test. And how can you do that? If you consider only one side of the graph, then the horizontal line test will pass, right? You could consider either this side, right or left. So for our discussion, let us consider that x, if I restrict domain, right, then I can ensure that inverse is a function. So how can we restrict domain? Let's restrict it by saying that let x be greater than or equal to, the vertex value of x is 1, so we'll say 1, right? If I do so, then we are only considering the positive half of the parabola. So when we consider positive half of the parabola, then the inverse will be f inverse of x will be actually equals to 1 plus square root of x minus 1. The positive half of our square root function, right? So this is how we are going to restrict our domain and ensure that the inverse is also function. See now, for every value of x, we have a unique value of f inverse x, correct? And therefore, this is a function now. So that's the way to restrict domain and ensure that the inverse is a function. I hope you understand. This is the last question of our quiz. And if you've done all these 10 questions, then you have really understood the chapter. So these questions were knowledge-based questions. So we do have application problems and thinking problems, which are separately dealt with. So once you've done all these knowledge-based questions, I will appreciate that you look into the questions relating to applications, thinking and communication. Okay, thank you.